Hi guys, welcome to the today's session of design and analysis of algorithms. In this session, we are going to discuss about the topics of Unit 5, which explains about divide and conquer algorithm design technique. In this unit, we are going to discuss about introduction to divide and conquer, recurrence equation for divide and conquer, applications. Here are 4 applications that we are going to discuss. Finding the maximum and minimum, merge sort, quick sort, and binary searching. Coming to the first topic, divide and conquer introduction. Divide and conquer is a general problem-solving strategy used in various fields, including computer science, mathematics, and engineering. It involves breaking down a complex problem into smaller, more manageable subproblems, solving those subproblems independently, and then combining their solutions to solve the original problem. So the name divide and conquer. It involves breaking down a complex problem into smaller problems. So we are dividing the problem into smaller problems. We are solving these subproblems independently, and then we are combining the solutions to get the solution of original problem. So conquering, we are doing conquering. That's why the name divide and conquer. So here this contains some general procedural steps in both the dividing and the conquering. So what the general steps that are present? Coming to dividing, divide the original problem into smaller and similar subproblems. This step involves breaking the problem into 2 or more parts that are easier to solve than the original problem. The key to ensure that the subproblems of the same nature as the original problem, but they are smaller in their scale. Coming to conquering, solve each of these subproblems recursively. If the subproblems are small enough to be solved directly, then we go for solving them. Otherwise, we will apply again divide and conquer method to each of these subproblems and breaking them down further into even smaller subproblems and so on. This process, applying of divide and conquer method to the subproblems continues till we get smallest subproblems which can be solved without further splitting. Once the subproblems are solved, combine their solutions to obtain the solution to the original problem. This combining step may involve merging, aggregating, or processing the results from the subproblems in a way that addresses the larger problem. Different applications follows different procedures in conquering the solutions. Here you can see a diagram which shows the divide and conquer method pictorially. So here you can see, here you are given a complex problem. This complex problem is divided into subproblems. Here we are dividing the complex problem into subproblems. This is one subproblem and this is other subproblem. Again, after dividing the complex problem into subproblems, again my problem is larger to solve. So here this problem is again divided into 2 subproblems as well. This problem is also again divided into 2 subproblems. Still, the problem is larger enough. So the problem again divided into 2 subproblems. Here also it is divided into 2 subproblems. Here also it is divided into 2 subproblems. Here also it is divided into 2 subproblems. Now here we are getting the solutions for all the subproblems. Here each subproblem is individually solved. So first we have taken a complex problem. That complex problem is divided into subproblems. If the subproblems are smaller, then we directly solve those subproblems. If the subproblems are not smaller, then again we will go for applying the divide and conquer method to these subproblems. So here the subproblems are again divided into subproblems, again divided into subproblems. We divide the problems into subproblems till we get the smallest problems, which can be solved without further splitting. Now, after solving all these subproblems, we need to conquer the solutions. Now, how we are going to conquer the solutions? So first, I saw the solution of this subproblem and the solution of this subproblem. These two subproblem solutions are combined to get the solution of this problem. Here, the solution of this problem and the solution of this problem are conquered to get the solution of this problem. Now, here these two are combined to get the solution of this problem. Here, these two are combined to get the solution of this problem, right? So after that, these two solutions are combined. Here we get solution for this problem. Here, these two solutions are combined. Here we get the solution for this problem. So then finally, these two solutions are combined to get the solution of given original problem. Right. I hope that you all understood how the divide and conquer problem works. Here you can see the control abstraction for divide and conquer method. Here you can see that is the general procedure is represented in the form of pseudocode or algorithm. Here you can see divide and conquer of P. If small of P, then return S of P, else divide P into smaller instances, P1, P2, so on, Pk, k greater than 1, and apply divide and conquer to each of these subproblems. Return, combine divide and conquer of P1, divide and conquer of P2, and so on, divide and conquer of Pk. Here you can see this control abstraction tells that it represents the general procedure what we have in the divide and conquer algorithm. Here P is the problem, complex problem what we are taking. K is the number of subproblems. Now, first it checks the problem P. If it is small enough, the problem can be solved directly. That is, it gives the solution of P. If the problem P is not small enough, divide it into K smaller subproblems. P1, P2, P3, so on, Pk. Right. Now, and recursively apply divide and conquer algorithms to each of these subproblems P1, P2, P3, so on, Pk. Right. Combine the solutions obtained from the subproblems using combine function. So here the combine function is used to combine the solutions which we are obtaining from P1, P2, P3, and so on, Pk. So this algorithm assumes that the problem can be divided into smaller subproblems and each subproblem can be solved independently. The combine function is used to merge the solutions obtained from the subproblems into a single solution for the original problem. So the algorithm's efficiency depends upon the efficiency of combine and small functions and the number and the size of the subproblems. So I hope that you all understood this divide and conquer general method. And coming to the recurrence relation for divide and conquer method, what is the purpose of recurrence relations? In the context of divide and conquer algorithms, recurrence equations describe the time complexity of solving a problem of size n in terms of time complexity of solving smaller subproblems. So here the recurrence relation is used to represent time complexity of solving a problem whose size is n in terms of its time complexity of smaller subproblems. Recurrence equations are essential for analyzing the time complexity of algorithms which are following divide and conquer strategy. The general form of recurrence relation for divide and conquer method is represented here. T of n is equal to T of 1 when n is equal to 1. A into T of n by b plus f of n when n is greater than 1. Here, when n is equal to 1 means n always represents the size of problem. When n is equal to 1 means if the problem is the smallest problem. Then T of 1, the time complexity of that problem can be represented as T of 1, that is, which is having a smallest time complexity. When n is greater than 1 means the problem is complex problem. It is not a smallest problem. In that case, the time complexity can be expressed as time complexity of its subproblems. Right. Here A and B are constants. And here T of 1 is to be assumed as a small constant, which is the time complexity required for solving the smallest subproblem. Here f of n is a function in n, which represents the time complexity for dividing the problem and for conquering the solutions. Now, when I solved this recurrence relation, there are a lot of methods are there for solving this recurrence relation. We can use substitution method, or we can use Master's theorem, or we can use recurring methods, recurring tree methods, like that. Different methods are there. When I used the substitution method to solve this recurrence relation, we will get the time complexity as T of n is identically equal to n power log a base b into T of 1 plus u of n. Here, you know the terms a, b. These are known constants. You know the term T of 1. This is also a known constant. What about this u of n? How we can get the value of u of n? Here you can see u of n is equal to sigma j is equal to 1 to n h of b power j. That is how I can express u of n. U of n is equal to h of b power 1 plus h of b power 2 plus h of b power 3, so on, h of b power n. Now, how to get the value of that h values? H is a function. How to get those values? Here, the function h can be represented as like this. H of n is equal to f of n by n power log a base b. I know the values of f of n, a and b values. When I substituted these values, I'll get the value of h of n. When I substituted h of n values, I'll get the value of u of n. And when I substituted u of n values, I can find the time complexity for a particular application which is solved using divide and conquer method. Here, we can get directly the u of n values corresponding to h of n without going for much complex solutions. Here we can get directly. If h of n is in the form of big O of n power r and r less than 0, we can get u of n value as big O of 1. If we get h of n value as big O of log n power I, here I is greater than or equal to 0. In that case, h of u of n can be represented as big O of log n power I plus 1 by I plus 1. So here, a big O of n power r, if h of n is in the form of big O of n power r, here r is greater than 0. In this case, the h of u of n can be represented as big O of h of n. Right. So by using this table, we can directly obtain the values of u of n by finding h of n. Just by I'll find by substituting f of n, a, b values, I'll find h of n. Then corresponding u of n values can be taken from the table. That u of n value can be substituted here and simplified. Then we can get the time complexity of a particular application which can be solved using divide and conquer. This method is to be called as a substitution method. And we can use Master's theorem as well to solve the recurrence relation in case of divide and conquer. Here the Master's theorem can be solved in 3 cases. Here you can see the 3 cases. If here the recurrence relation is in this form. Now in this case, the function f of n is in the form f of n is equal to n power k log power p of n. Here a is always greater than or equal to 1 and b is greater than 1. k greater than or equal to 0 and p is a real number. Now, here, case 1, if here we will check the values a and b power k. We will compare those two values. The a may be greater than b power k, a may be equal to b power k, and a may be less than b power k. So, 3 cases may be there. A may be greater than b power k, equal or less than. If the 3 cases, the 3 conditions can be represented in 3 cases. If a is greater than b power k, then the time complexity can be represented as big of n power log a base b. Case 2, if a is equal to b power k. In this case, we will check the value of p. P is greater than -1, then T of n is equal to big of n power log a base b log p plus 1 log power p plus 1 n. If p is equal to -1, in this case, T of n is equal to big of n power log a base b log of log n. If p is less than -1, then T of n is equal to big of n power log a base b. Now, case 3, if a is less than b power k. In this case also, we'll check p value. P is greater than or equal to 0, then T of n is equal to big of n power k log power p n. If p less than 0, then T of n is equal to big of n power k. Right. So directly by comparing the values of a and b power k and by checking the value of p in all those 3 cases based on the given recurrence relation, to which case it falls, those values falls. From that case, directly I can get the time complexity of any application by using these time complexity values. So I hope that you all understood the general method of divide and conquer method, divide and conquer algorithm design strategy, and also how to solve what is a recurrence relation and how to solve the recurrence relations using substitution method and Master's theorem, using Master's theorem. I hope you all understood. Thank you for listening the session. Thank you very much.